Hello and welcome to Mr. Tompkins EdTech. This series of videos provides work solutions for the GCSE Maths topic test produced by AQA. This video is Introduction to Quadratics and Rearranging Formula. Whilst these topic tests make excellent exam preparation and revision material, regardless of which exam board you're sitting, they are particularly useful for students studying for AQA as they are prepared by the same team who will be writing your papers in the summer. They will work best if you try and answer the questions yourself before watching the video. The topic test papers can be downloaded from this address, which I've also linked in the description below. They'll require a teacher account to access, so either ask your maths teacher to download and share them with you, or alternatively you can try pausing the video and attempting the question first before pressing play again to listen to my solutions. Check this playlist for all the other topics I've covered. I'm busy recording all of these topic tests, so if the particular topic you're looking for isn't there yet, why not drop me a comment below with your request and subscribe to my channel to receive notification of future uploads. If there is anything you don't understand, please ask in the comments. Make sure you mention the question number and try to be as specific as possible. I try to answer all questions promptly, especially around exam times. If you found the video useful, please do hit the like button, as this really helps me out. You might also like to check out my exam paper walkthroughs covering all the recent papers and practice papers from AQA. Just click on the card appearing at the top of the screen now. Okay, let's get started. So this is Introduction to Quadratics and Rearranging Formula for higher tier, produced by AQA. Question 1. Write down x cubed times x to the 5 divided by x squared as a single power of x. Now this problem is actually a problem about indices. All these numbers have the same base, so we can combine them into a single term. If I've got two numbers with the same base and I multiply them together, I'm going to be adding the indices. So my numerator part simplifies to x cubed times x to the 5 is going to be x to the power of 3 plus 5, which is x to the power of 8. And then, if I've got two numbers with the same base and I'm dividing them, so I've got a number with the same base here and I'm dividing them, then I subtract the indices. So it's going to be x to the 8 divided by x squared is x to the power of 8 subtract 2. It's going to be x to the power of 6. Part B says, write 3y to the power of minus 2 times 8y to the power of 5 divided by 6y to the minus 5 times y squared. So we're going to do a similar thing here. So you'll notice again we've got, notice we've got lots of y's raised to various powers here. This time though we've got some additional numbers as well. So we're going to have to deal with those separately. So we've got all those indices we have to deal with. But we've also got these two numbers here, haven't we? 3, 8, oh, and one down here as well, 6. So we're going to have to combine those together as well. So 3 times 8 is 24. So combining the two numbers on the numerator first, it gives me 24. And then I've got y to the power of minus 2 times y to the power of 5. So using the same laws of indices, negative 2 plus 5 is 3. So at the top, the numerator part of that quotient comes out to be 24y cubed. So moving on to the denominator, I've got 6 on the bottom, and I've got y to the negative 5 and y squared multiplied together. So two numbers with the same base, multiplied together, I simply add the indices. So that's going to be y to the power of negative 5 plus 2. That's going to be y to the negative 3. Okay, so finally, I can then divide these two things. So looking at the number part first off, 24 divided by 6. 6 goes into 24 4 times. So that's going to leave me with 4. Y cubed divided by y to the minus 3. If I divide two numbers with the same base, I subtract the indices. So I'm going to get y to the power of 3 subtract negative 3. 3 subtract negative 3 is the same as 3 plus 3, which is 6. So my answer is 4y to the power of 6. Okay, if you need any more help with indices, I made a topic test specifically about indices. I'll put a card in at the top of the screen now. So if you want some more practice of that, then perhaps you can have a go at that one next. Question 2. Expand and simplify x minus 5 times x plus 2. So I've got a double bracket multiplied together. So we need to multiply everything in one bracket with everything in the next. Some people remember this as a smiley face. Some people talk about FOIL, first outside, inside, last. Some people use a grid to do it. So you write x and minus 5 and x plus 2, like that. So I'm going to do it both ways, just to cover all the bases. So I can use it using grid multiplication. So x times x is x squared, x times 2 is 2x, x times minus 5 is minus 5x, and minus 5 times 10 is negative 10. Okay? Okay, if you want to try doing it by the FOIL method instead, let me just get rid of these lines and put them in again. So first off, if you use FOIL, first, outside, inside, last, the first thing you're going to be multiplying is the first two numbers from each bracket. So the first term in the first bracket times the first term in the second. So that's x times x. X times x is x squared. Outside is the terms on the outside of the bracket, the x and the 2. If I multiply those together, I get plus 2x. Inside is I multiply my two terms closest to the middle, so minus 5 times x, which gives me negative 5x, and then finally the last, so the negative 5 times the plus 2. Negative 5 times positive 2 is negative 10. Okay, you see I get the same results, and then what we then need to do is take our two middle terms, which either will appear here if you've done FOIL or if you've done it using the grid method, those ones along the diagonal, and we need to combine them into one term. So I've still got my x squared plus 2x minus 5x. 2 subtract 5 is negative 3, so it's going to give me negative 3x in the middle, and minus my minus 10 from before. So x squared minus 3x minus 10. Like I say, either method is fine. Pick the one that works best for you. Okay, in question 3, I need to make w the subject of this formula. So the w is here. Luckily it only appears once, so it's a simpler sort of rearrangement. So now if I was working out p, I would take w, I would times it by 2, and then I'd add on 2 lots of l. So if you want to get w by itself, you need to use inverse operations to unwind this calculation. And you can kind of do it in the opposite order of BIDMAS because we're using inverse operations. So you want to kind of work your way back through BIDMAS when you're rearranging something like this. So as I say, if I was working out p, I'd be taking w first, I'd be timesing it by 2, and then I'd be adding on 2l. So if I'm rewinding it, then I'm going the opposite way, so that my addition comes last, so it's the first thing I'm going to move over. So I'm going to move that over to the other side of the expression, or the equation, sorry. So I'm going to get p subtract 2l is equal to 2w. Okay, and then I would have been multiplying by the 2 first, so that's going to be the last thing I move across. So the opposite of timesing by 2 is dividing by 2. So that gives me p subtract 2l over 2 is equal to w. Okay, now it's perfectly fine like that, but if you want to flip it around and write it the other way, there we go, that way around. Question 4a, factorise x squared minus 36. Now you should immediately recognize this quadratic for what it is. It's what we call the difference of two squares. Now it's called that because that's what it is. I've got two squares. I've got x squared and 36, and I'm taking one away from the other, which mathematically we call the difference. So that's why it's called the difference of two squares. Now the difference of two squares has a identity that you can make use of. It says a plus b times a minus b is identical to a squared minus b squared. And this is something you just need to remember. Crops up pretty much every single exam paper without fail. So it's an important result that you need to know. Okay, so once you do know that identity, it's very simple to factorise this expression. I'm going to have two brackets, and I'm going to take the square root of my first term, x, and write at the front of my brackets. I'm going to take the square root of my second term, square root of 36 is 6, I'm going to write it at the end of both my brackets, and I'm going to make one bracket plus and one bracket minus. And that's my answer. If you're not sure why that gives you x squared minus 36, just try multiplying it backwards and you'll see that you get two middle terms that are equal but opposite signs, which cancel each other out. Okay. Similarly, 4b, factorise fully 9y squared minus 16. Again, this is just a difference of two squares. It's going to factorise into a double bracket. I need to take the square root of the first term, and that's going to be at the front of both my brackets. What's the square root of 9y squared? Now, when you've got an index of an index, that's like 9y squared to the power of a half, isn't it? Same thing. You have to distribute that to each term, so you're actually square rooting 9 and you're square rooting y squared. So the square root of 9 is 3 and the square root of y squared is y. So I'm going to have 3y at the front of both my brackets. And the square root of 16 is 4, so I'm going to have 4 at the end, and I'm going to have 1 plus, 1 minus, because I know it's the difference of two squares. Question 5. Simplify fully 6a plus 2b plus 3a minus 8b, all divided by 10a minus 3b plus 5a minus 7b. Okay, so first off, let's try and collect like terms. So I've got 6a and a 3a up here, I've got 10a and a 5a down there. I've got a plus 2b and a minus 8b on the top, and a minus 3b and a minus 7b on the bottom. Now notice I'm highlighting the sign along with the term because those two things belong together. So I've got 6a plus 3a on the top, which is 9a, and I've got 2b minus 8b. 2 subtract 8 is negative 6, so that's going to give me minus 6b. So that's my numerator. On the denominator, I've got 10a plus 5a, which is 15a, and I've got negative 3b subtract 7b, which is minus 10b. Okay, are we done? I think we can factorise a little bit here, can't we? So I've got 9a minus 6b on the top, so they have a common factor of 3. So I can pull out a 3 of those two terms and rewrite that as 3a minus 2b on the top. Similarly, on the bottom here, I've got 15 and 10, so they have a common factor of 5. So if I pull that out, then I'm going to get 3a minus 2b, 5 lots of 3a minus 2b on the bottom. Okay, but now I can see that 3a minus 2b on the top and 3a minus 2b on the bottom, those two things are going to cancel each other out. So it's just going to leave me with my 3 over 5. A surprisingly simple result. So there we go, done. Question 6. Factorise x squared plus 5x minus 14. Okay, so we've got a quadratic. It should factorise into a double bracket if it's going to factorise. Now my first term is x squared, which means I must have an x here and an x here, which multiply together. If I did FOIL on those brackets, first, outside, inside, last, I'd multiply the first with the first, and that would give me the x squared. Now, I would also multiply the last with the last, and that would give me negative 14. Okay, so that gives me a bunch of possible values. How can I get minus 14? I could get negative 14 by multiplying negative 1 and 14, or 1 and negative 14. Or it could be 2 and negative 7, or negative 2 and 7. They're my possibilities, aren't they? So it's a matter of thinking about each one in turn and think about which one is going to deliver you plus 5x in the middle. Minus 1 and 14 adds up to 13, so that's no good. 1 and minus 14 is negative 13. 2 and minus 7 is negative 5, and minus 2 and 7 is 5. So that's the one we're after then, isn't it? Negative 2, 7. So I'm going to have x subtract 2, x plus 7 as my solution. Question 7. Here is a rectangle. The length is 3x minus 1 and the perimeter is 10x. Work out an expression for the area in the form ax squared plus bx plus c. Okay, so we know the perimeter and we know one of the lengths. Now the perimeter of a rectangle is 2 lots of the length plus the width. So we get that because I've got 2 lengths here and here that I add together to get the perimeter, and 2 widths added together. So length plus the width, or the other way of thinking about it is length plus width doubled up. So I've got perimeter equals 2 lots of length plus width. Now I know the perimeter and I know the length. What I don't know is the width. So let's sub in what I do know. We know that the perimeter is 10x, and we know that the length then is 3x minus 1. So I've subbed in that and I subbed in 3x minus 1. What I don't know is w. Okay, so first off, dividing both sides by 2 or cross multiplying that 2, whichever way you want to think about it, I'm going to end up with 5x on the left. 10x divided by 2 is 5x, and that is going to be 3x minus 1 plus w. So then taking my 3x over to the other side, or subtracting 3x from both sides, and moving my negative 1 over to the other side, or thinking about it as adding a 1 to both sides, I'm going to get 5x take away 3x, which is 2x, and that negative 1, when it comes over to the other side, is going to become plus 1. So I'm going to get 2x plus 1 is equal to w. So that means my width then is 2x plus 1. I just write it up there on the diagram. So we're kind of half done now. Let's just draw a line here. We'll start our second part of the calculation. Now we need to work out the area. Now the area of a rectangle is length times width. So I now know both of those, don't I? I already knew that the length was 3x minus 1, but I now know that the width is 2x plus 1. So now it's a matter of doing FOIL or the grid method to work out what a is. So 3x times 2x, the first times the first, it's going to give me, it's going to give me 6x squared. Outside, 3x times positive 1 is 3x. Inside, minus 1 times 2x is minus 2x. And last, negative 1 times 1 is negative 1. Okay, almost done. Just need to collect those middle two terms together, my 3x and my minus 2x. And then we're done. So 6x squared, 3x minus 2x is x, so it's plus x minus 1. So I've got my expression in the form ax squared plus bx plus c, where a is 6, b is 1, and c is minus 1. All done. Question 8. The curved surface area of a cone is given by a is equal to pi rl. The volume of the cone is given by v, which is equal to 1/3 of pi r squared h, where l is the slant height, h is the perpendicular height, and r is the radius. Right, rearrange the area formula to make r the subject. So I've got a is equal to pi rl. That's what was given, and I need to make r the subject. So I need to cross multiply my pi and my l to the other side, or divide them through both sides by pi and l, if that makes more sense to you. That will give me r is equal to a divided by pi l, like that. Okay, part B. Write down a formula that connects L, H, and R. Now, looking at my diagram, I can see that L, H, and R are here. Look, they form a right angled triangle in the diagram. So I can write down a formula that connects them, because I know that in Pythagoras' theorem, the longest side of a right angled triangle is equal to the sum of the squares of the other two sides. So that means I can say that L squared, the long side of my triangle, the hypotenuse, is equal to the other two sides squared and added together. That's going to be h squared plus r squared. So now I've got a formula that connects L, H and R together. Okay, and then finally it says work out the volume formula in terms of pi, r and L only. So currently the volume formula has got a h in it, so I need to replace the h with something that only has pi, r and L in it. Okay, so it's going to have to be, I'm going to have to use this formula, aren't I? So I'm going to use this formula here to replace h in this formula up here. So v equals 1/3 of pi r squared h. So I know that v equals 1/3 of pi r squared h. So what I need to do is to take this formula up here, rearrange it for h. So what's that then? So that must be h squared equals L squared minus r squared, and then taking the square root of both sides, h then is going to be the root of L squared minus r squared. Okay, so now I've got that, I can replace it in my formula for v here. So I can remove the h that's on the end of that formula and plug in my root L squared minus r squared instead. So I can just say then that v equals 1/3 of pi r squared, open bracket, L squared minus r squared to the power of a half. I just rewrote that in index notation. I could have written it, of course, like this as well, but I think this way is neater. Well, that's that. I hope you found the video useful. If you did, please hit the like button and consider subscribing to my channel. Also, check out the playlist on the right for more topic tests, or the one down below for past papers. See you again next time.